Hey everyone, and welcome to The Explainer. So today, we're going to unpack something that honestly feels like pure magic to a lot of people. Think about it. Every time you send a text, stream a movie, or just load a web page, your data is literally crossing the globe in milliseconds. To most of us, the internet is just this mysterious black box, right? But it's really not magic at all. It's actually a highly structured, meticulously designed system. And today, we're going to pry open that box and completely demystify cyberspace by exploring the famous 7 layers of the OSI model.
Okay, let's dive into this. Here's our game plan for today's top-down journey. First, we'll look at why layered architecture even matters. Then, we'll hit the software layers, 7 down to 5. Next up, the delivery layers, 4 and 3. After that, we drop down to the hardware layers, 2 and 1. And finally, we'll wrap it all up with securing the full stack.
Now, I want you to just think about this for a second. How does a simple tap on a piece of glass in the palm of your hand travel across oceans and continents, hit a server, and then come all the way back with the exact information you wanted, almost instantly? Well, by the end of this explainer, you're going to see that this isn't abstract wizardry. It's actually a highly logical, step-by-step relay race.
So, Section 1. Why layered architecture matters.
Look, computer networks are literally mind-bogglingly complex. If you had to understand the deep physics of a fiber optic cable just to build a simple website, yeah, nothing would ever get done. And that is exactly where layer of architecture comes to the rescue. It takes all of that massive complexity and divides it up into manageable, bite-sized functions. The absolute beauty of this setup is that each layer provides specific services to the layer directly above it, while relying on the services from the layer directly below it. It's the ultimate division of labor. And this brilliantly illustrates why this matters so much. On one side, you've got a web developer, right? They can spend their entire day building secure HTTPS applications without needing to know a single thing about how light pulses through a submarine cable at the bottom of the ocean. And on the flip side, a network engineer can expertly route IP packets all over the globe without knowing the first thing about coding an HTML button. These layers allow specialists to just focus on their specific job without accidentally breaking the entire global system.
Now, the gold standard we use to understand this massive division of labor is called the OSI model. And the magic number here is 7. There are exactly 7 distinct layers in this model. So today, we are going to peel back the curtain, layer by layer, to see exactly what happens to your data.
Which brings us to Section 2, Software Layers, 7 to 5, the digital interface.
We're kicking off our top-down journey right where you actually interact with your screens. These top 3 layers are essentially the digital interface between human intentions and the network itself.
Right at the very top is Layer 7, the application layer. Its primary purpose? Providing network services directly to the apps you use every single day. So when you type in a web address, you're using Layer 7 protocols, like HTTP to browse the web or DNS to translate a domain name into an IP address. But because it's so close to the user, it is a massive target for hackers. The major cybersecurity threats here revolve around application vulnerabilities. A classic, really dangerous example is bad input validation. This is when an attacker types a malicious database command into a simple login box, just crossing their fingers that the application will blindly execute it.
Moving one step down, we hit Layer 6, the presentation layer. If Layer 7 is the conversation, think of Layer 6 as the translator. Its purpose is to make sure the data is in a readable format. It handles things like character encoding, data compression, and, crucially, encryption. You know that little padlock icon you see in your browser bar? Yeah, that's TLS encryption, and it's happening right here. But what about the threats? Well, hackers are always hunting for encryption flaws, or they target something called unsafe deserialization. I know, it sounds super intimidating, but just think of it like someone sneaking a tiny bomb into a flat-packed piece of furniture. The hacker manipulates the data while it's being unpacked from storage back into a running application, basically tricking the system into executing malicious code.
Next up is Layer 5, the session layer. Imagine you're logged into your online bank account. You don't have to re-enter your password every single time you click a new tab, right? Well, that's Layer 5 hard at work. Its whole purpose is to establish, manage, and terminate communication sessions between applications. It's what keeps you logged in securely. But there is a severe risk here, and it's called session hijacking. If an attacker manages to steal your unique session identifier, they can literally step into your digital shoes and completely control your account without ever even knowing your actual password. Crazy, right?
So, just to quickly recap these software layer threats, we've got application vulnerabilities up at Layer 7, unsafe data deserialization at Layer 6, and session hijacking at Layer 5.
The absolute key takeaway for you here is that hackers absolutely love targeting these top layers. And the reason is pretty simple. This is where the actual, unencrypted, highly valuable user data lives before it gets all chopped up and sent across the network.
Moving right along to Section 3, Delivery Layers 4 and 3, Packaging the Data.
Now, what's really interesting about this slide is how it clears up a super common point of confusion. People mix up the transport and network layers all the time. But let's think about it like a postal system. Layer 4, the transport layer, is the envelope. Its job is to ensure the contents get from the sender's hands to the receiver's hands in one complete piece. Layer 3, the network layer, is the actual mail truck and the GPS system. It's figuring out the absolute best roads to drive on to get that envelope to the right zip code.
Let's look a little closer at Layer 4, the transport layer. As we said, its purpose is end-to-end delivery. And the two heavy hitters you need to know here are TCP and UDP. TCP is the reliable one. It literally double-checks that every single piece of data arrives in perfect order, which is exactly what you need when you're loading a web page. UDP, on the other hand, is the fast, kind of reckless one. It just throws data at the receiver without stopping to check if it arrived. But that's actually perfect for things like live video calls, where speed matters way more than perfection. As for threats, attackers will use port scanning to probe for open doors into your system, or they'll launch SYN floods. That's a nasty type of denial of service attack that just overwhelms a server with half-open TCP connections until the whole thing completely crashes.
Dropping down to Layer 3, the network layer, the purpose shifts to logical addressing and routing across the vast global internet. This is the home of the Internet Protocol, or IP. Literally every device gets an IP address, and routers use this layer to figure out the absolute best path to send your data packets across the world. The major cybersecurity threat to watch out for here is IP spoofing. This is where an attacker forges the source IP address on a packet, completely disguising malicious traffic to make it look like it's coming from a trusted, friendly system.
All right, Section 4, Hardware Layers 2 and 1. We are now entering the physical world.
These final two steps are where those logical, digital IP addresses are translated into actual, physical reality. This is exactly how data physically jumps from your laptop over to the router sitting in your living room.
So, Layer 2 is the data link layer. While Layer 3 was all about global routing, Layer 2 doesn't care about the rest of the world. It is only concerned with the local network, just getting data to the very next physical device. Its purpose is moving local network frames using physical addresses, which you've probably heard of, MAC addresses. We're talking about your local Ethernet or your Wi-Fi connections here. A super common cyber threat at this layer is ARP spoofing. This is where an attacker on your local Wi-Fi basically tricks your computer into thinking their device is the actual network router. And suddenly, all of your data is flowing straight through the attacker's machine before it ever hits the internet.
And finally, we arrive at the very bottom. Layer 1, the physical layer. The entire purpose here is the transmission of raw ones and zeros. Just raw bits being sent over a physical medium. We are talking about tangible things you can touch. Copper Ethernet cables, radio waves for your Wi-Fi, and those massive fiber optic submarine cables crossing the ocean floor. And because it's physical, the threats are physical. Fun fact, tech companies actually have to repair those submarine cables sometimes because sharks literally try to bite them. No joke. But on a human level, a hacker doesn't even need to write a single line of code to take down a network if they can just cut a power cable, physically tamper with a router in a closet, or use a radio jammer to kill a Wi-Fi signal.
Which brings us to our final stop, Section 5, Securing the Full Stack, Defense in Depth.
So the crucial point is that the OSI model is not just some boring diagram you memorize from an IT textbook. It is a literal battle map. Hackers don't just magically attack the internet. They target highly specific weaknesses at specific layers. Maybe they exploit a Layer 7 app flaw, or maybe they launch a Layer 3 spoofing attack. But as defenders, we don't have the luxury of choosing just one layer to care about. We have to protect the entire stack. And this is exactly why we need defense in depth, building multiple layers of security controls. That way, if an attacker manages to bypass one layer, another layer is right there to stop them in their tracks.
I want to leave you with this thought because it really sums it all up. Defending cyberspace requires protecting every single layer, from the physical cables to the web browser. You can have the most advanced, expensive Layer 7 application firewalls in the world, but if someone just walks into your building and unplugs your Layer 1 server rack, your security has completely failed. It is all connected.
Which brings me to a final question for you to really chew on as you study network security. If an attacker only needs to successfully breach one single layer to compromise your entire system, which layer in your own digital life is your weakest link?
Are you maybe reusing passwords up at layer 7? Or are you completely ignoring physical security down at layer 1? I hope this explainer has given you the map you need to start finding those answers. Keep exploring, stay curious, and stay secure.